The teaching of Vedantu was amazing. One aspect where Vedantu teaching differed from a normal offline coaching was the attention teachers gave to our doubts. No matter how many times we asked a doubt, the teachers would patiently clear the doubt every single time. And they made learning a very fantastic experience for us.
Hello guys, this is Saurav here and welcome to another session on the Vedantu channel for the grade 12th chemistry, and this is the first lecture on chemical kinetics. I welcome every one of you who have come to attend this lecture, and I would be taking chemical kinetics in a very systematic, very simple manner. Mathematical है, okay, and बहुत ही खूबसूरत topic है, बहुत easy topic है. You do not have to chemistry component is very less. Okay, to be very honest, in chemical kinetics the chemistry component is very less, the mathematics component is a little more. Okay, so we start today's topic, and this is the introductory lecture. We'll try to learn what are the first things, first vocabulary for to learn chemical kinetics. Now please do like, share and subscribe the channel, as I always tell you in every session, so that the word reaches out to everybody. And this is the flow that we would be following. So you can see that the chemical kinetics is the major topic, and we will be covering the topic in two subsections. One where we would be discussing about the rate of reaction, and the second section would be where we would be discussing about the temperature dependence of rate. आपने देखा होगा कि अगर आपने temperature increase किया, then rate of reaction increases in almost most of the cases. Okay, now the rate of reaction, there are three important parts. We would be discussing rate law, order and molecularity, zero, first and nth order reactions, their characteristics, and we'll solve some problems. The most important part among these, the first subsection, is the first order reaction and the zero order reaction. Avneeraj Kumar for physical chemistry, sufficient JEE Mains. Yep, it's based. Any book is good. Okay, any book is good. So zero and first order reactions are more important. Temperature dependent collision theory, Arrhenius equation. Remember that from chemical kinetics, every year about one or two questions will come in JEE Mains. So hello Manoj, hello Preetam, and so it is important that you master this topic and do it in a very systematic, in a simple way. Try not to overly complicate it. बहुत simple तरीके से समझने की कोशिश कीजिए. And yes, this chapter is quite easy. अरे DC पांडे मैथ्स केमिस्ट्री का किताब नहीं है. अब केमिस्ट्री क्लास में आके फिजिक्स की किताब के बारे में पूछोगे तो मैं कैसे बता पाऊंगा. ओके ठीक है. So problems, most of the times we'll be covering problems, but पहले थोड़ा theory भी हम cover करेंगे. Okay, we'll cover a bit of theory, because unless and until you are thorough with the theory part, it is impossible to have a conceptual understanding. And examination में questions आएंगे तो शायद आपने problems ज़्यादा solve कर लिए हैं, you will not be able to solve questions which are entirely new. Okay, so we start the lecture by understanding what does chemical kinetics talk about. Okay, what does chemical kinetics talk about? Chemical kinetics deals with the rate of reaction. देख लीजिए, branch of chemistry which deals with the speed of reaction, the sequence of steps which in which a reaction takes place. So if I look at the speed of reaction, what is the meaning of speed of reaction? In a reaction, you must have seen that there are reactants and there are products. चाहे reaction किसी भी तरह का होगा, वहाँ पे एक reactant तो होना ही है, and a minimum of one product would be there. Okay, so minimum of one reactant, a minimum of one product. Now rate, ever the word rate comes into picture, the meaning of rate is that the time in which a certain variable is changing. Over here, the variable that is changed is concentration. हम किसी और चीज को चेंज नहीं कर रहे हैं, हम लोग कॉन्सेंट्रेशन को चेंज कर रहे हैं, एंड दैट इज व्हाट वी ट्राई टू स्टडी इन केमिकल काइनेटिक्स. सो द स्पीड ऑफ रिएक्शन इज द रेट ऑफ रिएक्शन. ओके, प्रोडक्ट कितना जल्दी फॉर्म होगा या फिर रिएक्टेंट कितना ज्यादा जल्दी कंज्यूम हो जा रहा है. ओके, so speed of reaction is the rate of reaction. Now another point that a lot of people think is interrelated is known as spontaneity, and it talks about the feasibility of a process. For example, I allow this pen to fall towards the ground. That is a feasible process. The pen automatically does not come up. That's a non-feasible process. Water falling from the top of a mountain, that's a feasible process. Evaporation of a liquid, feasible process. Melting of solidification of wax is a feasible process. But does this mean that feasibility has anything to do with the rate? No. Feasibility is a separate assessment. Thermodynamics में वो assessment करते हैं, and rate का assessment chemical kinetics में होता है. So याद रखो, don't try to say that if our speed is less, it is not feasible. Try and understand. मैं एक बहुत simple सा आपको idea दे देता हूँ. So speed is not related. It's not related to a spontaneity. Speed is not related to spontaneity. ये हो सकता है कि एक slow reaction है but feasible. But it is also possible that there is a fast reaction but non-feasible. So it is quite possible. Okay, spontaneity and speed का कोई relation नहीं है. ठीक है, speed is less than rate of reaction is less. Yes, that is correct. चलो अच्छा है कि spontaneity chemical kinetics में नहीं है. Spontaneity chemical kinetics में नहीं है and इसको relate भी नहीं करना है. Please don't relate this. A slow reaction can be feasible. A fast reaction can be non-feasible. Clear? Let's try and look at few scenarios. Okay, let's try and look at few scenarios. So what you are seeing over here is, okay, what you're seeing over here are certain reactions. Can you see this? The first one is rusting of steel. The first one is rusting of a steel, and there's a day clock. So आप देख सक रहे हैं कि the rusting process, this has been like fast forward करके हमने लिया, time lapse video है ये. So it takes a lot of time for the reaction to take place. Okay, it takes a lot of time for rusting to occur. The second reaction is addition of sodium chloride in a solution of AgNO3. So what I'm doing is I'm adding sodium chloride in a solution of AgNO3, and what will happen because of this is that जैसे ही वो sodium chloride AgNO3 को touch करेगा, it will convert into AgCl, and AgCl is gonna be precipitated. You can see that this white thing is the precipitate. This white thing is the precipitate, and the precipitate is being formed very, very quickly. So this is a slow reaction and this is a fast reaction. There are certain reactions which are ultra fast. For example, explosion, crackers. Okay, they are ultra fast. The gunpowder ka explosion, gunpowder's reaction or decomposition of gunpowder. So crackers, that's an ultra fast reaction. Okay, but there are certain reactions which are of intermediate rate which we can study. Okay. Shubham, the white thing is silver chloride. It's a silver chloride precipitate. Silver chloride ban raha hai and it is getting precipitated. There are certain reactions which have intermediate rates and which we can study. So, like if you look at a nucleus at times emits certain particles in the process of natural radioactivity, which is giving a disintegration of nucleus, and it gives out some particles. You can see that some particles will be given out. So एक particle अभी निकला, so particle इस तरह से निकलेगा, and this particles will be either alpha particle, beta particle, gamma rays, positron, neutron. All of these are of intermediate rate, and this we can study. There are so many reactions which we can study, like decomposition of hydrogen peroxide, reaction of hydrogen and chlorine in sunlight, decomposition of nitrogen pentoxide, esterification reaction, decomposition of an ester, hydrolysis of an ester. So these reactions are something that we can study under laboratory grade conditions, but these reactions are too damn specialized. मतलब इनको पढ़ना बहुत मुश्किल है. Slow reaction इतना slow रहता है कि we cannot study that quite easily. Okay, so it will take a lot of time for a small amount of reaction to take place. Fast reaction will take place so very quickly that it will be difficult to study. Ultra fast reaction को study करने के लिए एक specialized mechanism होता है, that's known as a separate branch of chemistry known as ultra fast chemical kinetics. Okay, so chemistry of ultra fast reaction, that's entirely different reaction. Okay, now intermediate would be a time which is like varying from probably like 5 minutes or some minutes to probably few hours. I can study those reaction, but I cannot study a reaction which takes about like a week or a year to take place. Okay, rusting is a slow reaction. Yes, it's written over here, rusting is a slow reaction. Okay, let's move ahead. So what is a rate of reaction? Okay, what is the meaning of rate of reaction? So rate, the moment I introduce the word rate, आपने rate यहाँ पे पढ़ा होगा, rate of change of velocity, rate of change of displacement. Okay, in this chapter what reaction would be? I didn't get you, Ajay. Okay, so in physics also you must have read that rate of change of displacement, rate of change of velocity, what is the meaning of rate? The change of displacement in a given amount of time, change of velocity in a given amount of time. So rate of reaction can be estimated using either reactants or products. If I take any reaction, okay, so a reaction takes place like this. Reactant changes to products. A reactant changes to products. So if I start with a certain amount of substance, let's say I start with 10 moles of reactant, initially the product 0 रहेगा. Okay, initially the products will be 0, and slowly this will get consumed, isn't it? This will become 9, this will become 8, and slowly this will decrease, and this will slowly increase 1, 2, 3, and slowly it will increase. So over a period of time you will see that the concentration of reactant is changing, the concentration of product is also changing, the time taken. Okay, Ajay Singh, we will study intermediate rates. Okay, slow nahi पढ़ रहे हैं, fast nahi पढ़ रहे, we will study intermediate rates. Try and understand. So what you are seeing that the amount is changing. So change in concentration of reactant or product divided by the time. If I calculate the change and divide it by the time, I get the rate of reaction. Okay, if this is clear, please do say yes. सबको समझ में आ गया होगा कि हमारा दोनों चीज चेंज हो रहा है. ओके, रिएक्टेंट भी का भी अमाउंट चेंज हो रहा है एंड प्रोडक्ट अमाउंट इज ऑल्सो चेंजिंग. सो आई कैन कैलकुलेट द रेट ऑफ रिएक्शन बाई ऑब्जर्विंग द चेंज इन कॉन्सेंट्रेशन ऑफ रिएक्टेंट और प्रोडक्ट and dividing it by the time it takes. Okay, so let's move ahead. There are two types of rates. Okay, before I discuss the mathematical form of it, there are two types of rates. One is average rate and one is instantaneous rate. So average rate is calculated in a manner that the overall rate measured over a given period of time. Overall rate measured over a given period of time. So पूरा overall rate measured over a period of time. एक बहुत बड़ा time को ले लेते हैं and उसमें हम जितना change हो रहा है we use that to calculate the average rate. Okay. The instantaneous rate means I calculate it at a specific instant. I calculate it at the specific instant. Now why should we do this? Why should we do this? Average rate कहाँ use करते हैं? Okay. The question is, where should I use average rate and where should I use instantaneous rate? Okay, the question is, where should I use average rate? I know a lot of people know this formula because you have calculated average velocity, instantaneous velocity. So ये चीज़ें आपने calculate की हैं. But my question is, in a chemistry question, how should you be able to identify where to use average rate and where to use instantaneous rate? How to do that? So let's take a very simple example and I want your participation in this. Let's take an example of two students who are present with us right now. So let's take Preetham for example. So this guy is Preetham Okay, this guy is Preetham. Okay, and let's take Ajay for example. Very hard-working students. Both of them are very hard-working students, and they work a lot. They have been very diligent. शुरुआत से लेके अंत तक बहुत पढ़ाई कर रहे हैं. They are doing everything very nicely. They are like ideal students. Okay, Preetham is working hard. Ajay is also working hard. Everything is very nice. Now the parents get very happy. Okay, इनके parents बहुत खुश हो जाते हैं. Very happy. And they give, as दशहरा आने वाला है, October will be the दशहरा season, दिवाली आ जाएगा उसके बाद. So the parents become so damn happy that the parents give Preetham 10,000 rupees and Ajay also gets 10,000 rupees. Okay, Preetham gets 10,000 rupees, Ajay also gets 10,000 rupees. Clear? Preetham gets 10,000 rupees and Ajay also gets 10,000 rupees. Clear? So आप लोगों को 10,000 rupees मिल गया है, and let's say you have gotten this money on 1st of October 2019. 1st of October 2019 को आपको ये पैसा मिलता है. Clear? You have gotten 10,000 rupees, both of them. This is the amount of money that आपने कभी ये देखा ही नहीं है. You haven't ever seen this amount of money. Okay? आपको 10,000 rupees hard cash मिलता है. And so what you do is, what Preetham does is, Preetham goes to his school and tells his friend that, guys, I am loaded. So there's a party at my place. Please come. So Preetham throws a party. Okay? Preetham throws a party. But Ajay, he doesn't tell anybody कि मेरे को कुछ पैसे मिले भी हैं, and Ajay just thinks that, man, I have to save this money. I will spend only 10 rupees a day. Preetham throws a party and Ajay thinks that I will spend only 10 rupees a day. So what happens that on the 2nd of, or probably like the 5th of October, probably on the 5th of October, Preetham has spent probably 5,000 rupees in a party, and by 5th of October, Ajay has spent only 50 rupees. So the amount of money that he has is 9950. Okay, now Preetham just realizes that I have 5,000 rupees are gone. 5,000 rupees are gone. So he comes to his friends and tells them that, okay, fine, I have to save money. But his friends are like really like they see an opportunity, and वो प्रीतम को बोलते हैं कि भाई देख यार 5,000 रुपीज़ हैं, पैसा तो हाथ का मैल है, सो ऐसा कर तू स्पेंड कर दे. You at least give a small party on Diwali or something, or like about 10th of, और थोड़ा स्पेंड कर दे. तो प्रीतम सोचता है कि ओके फाइन, ठीक है, लेट्स स्पेंड सम मोर. सो अबाउट ऑन द 10th of October, Preetham is left with 1,000 rupees. Preetham is left with 1,000 rupees, and Ajay is now having 9,900 rupees. Okay, Ajay is 9,900 rupees. So how do we see Preetham's and Ajay's behavior? What Preetham is doing is spending the money very rapidly, very rapidly. So what he has been doing is, after 10th of October, he realizes that until next year, I'm not gonna get any money. So he reduces his spending to a very large extent. Earlier, the extent of spending was very high. Now he reduces spending to a very large extent. So if I plot Preetham's tendency to spend, okay, so this is the money versus time. So for Preetham, if I plot the rate at which his money is changing, can I say that the change in Preetham will be something like this, and as the time progresses, it will become very slow. So you can see that initially he has spent the money very fast, so slope is very high, and now it will decrease over a period of time. The rate at which or the extent to which Preetham is spending money will decrease. He has now realized. Okay. What about Ajay? What about Ajay? How is Ajay spending money? Ajay is spending money in a uniform fashion, and it will go like this. Can I say? So Ajay will be spending it like a smooth decrease of uniform slope. Smooth decrease of uniform slope. Is this understood? So let me erase this part. So for Ajay, this is money and time. Okay. Ajay has a constant slope in spending. Now the point is, if Preetham gets more money, let's say in the next year his parents become more happy and they give him 20,000 rupees or probably 25,000 rupees for spending, Preetham would be more than happy and he'll spend even faster, because his habit is like he wants to chill out with his friends, and so he'll spend even faster. But if Ajay gets 25,000 rupees or even 1 lakh rupees in his hand, do you think Ajay will be spending more than 10 rupees a day? Kya bolte ho aap? Will Ajay spend more than 10 rupees a day even if he has 1 lakh rupees or 1 lakh rupees or even 25,000 rupees? No. So the spending power of Ajay is independent of the amount of money that he has. Okay. So can I say that the rate of spending by Ajay rate of spending by Ajay is independent of the money? And how do we make it independent? How do we make it independent? 0. Okay. 0. Can I say this? Rate of spending by Ajay will be independent of the money that he has in his hand. Okay? Power 0 हो जाएगा. But obviously the rate of spending by Preetham will be proportional to the money to the power some positive value. To the power some positive value. तो मनी जितना इंक्रीज करता जाएगा उसकी रेट ऑफ स्पेंडिंग भी उतनी इंक्रीज करती जाएगी. ओके. सो नाउ इट इज इंपॉर्टेंट टू नो कि कहां पे हम कैसा रेट यूज करेंगे. ओके. इफ आई कैलकुलेट a change in the amount, at these 2 points, okay, at these 2 points for this time interval, okay, change in amount for this time interval, I would be getting, so this is money value 1, this is, let's say this is value 2, this is value 1, sorry, this is value 1, this is value 2, this is time 1, this is time 2. If I calculate the change, how do I calculate the change? Change will be calculated as V2 minus V1 upon T2 minus T1. Okay, V2 minus V1 and T2 minus T1. Okay. Are we calculating what is the value that I am getting? Let's say I get a value Z. Let's say I get a value Z. If I use the initial point and the final point, or any 2 points in this case, would I get the same value Z or not? Would I get the same values or not? Are you getting my point? I choose any 2 points where I see the change. If I choose the initial and the final point, would I get the same change or not? Yes. Change is nothing but this is the slope. So ये same slope आ जा रहा है एट एवरी पॉइंट, आप कुछ भी पॉइंट ले लो, ठीक है। सो इस तरह के प्लॉट में आप कैलकुलेट क्या करोगे, एवरेज। इन दिस केस यू विल कैलकुलेट एवरेज, बट कैन यू कैलकुलेट एवरेज ओवर हियर? If you try to calculate average over here, it is very very difficult, because, or difficult, but it's not difficult, आप easy भी है, but it is not going to give you the right result. It is not going to give you the right result. In this plot, I take this change and I take this change. I would observe that the change will give me the two different rates. Okay, ये जो change होगा, the rate of change of money in that given amount of time will be different. So in this case, I cannot use average, I have to use instantaneous. So what is the meaning of instantaneous? I would be using a very small change in a very infinitesimal small amount of time. So in this case, I will calculate instantaneous. In future, if you want to relate this to reactions, in future, if you want to relate this to reactions, you will relate it like this. You will relate it like this. So if this is concentration versus time, this is concentration versus time. So if I try to calculate average rate, okay, सर ये टॉपिक टफ है क्या? अभी तक आपको टफ लग रहा है? अभी तक आपको टफ लग रहा है? So you will get two types of plots. Okay, you will get two types of plots. For concentration versus time, you will get this kind of a plot. For concentration versus time, you will get this kind of a plot. Okay, so my point is, for this kind of a plot, if I try to relate the rate of change of concentration, rate of change of concentration with respect to concentration, with respect to the amount of substance that is taken, can I say this will be a positive value? This power will be a positive value. And for this rate will be proportional to concentration to the power 0. This will be concentration to the power 0. Okay, exactly the same replicated model, same model has been replicated over here. This thing that you are seeing over here, in the next few classes we will come across this thing. This thing is known as the order. Order tells us the dependence of rate on concentration. The dependence of rate on concentration is given by the number that will come over here. Okay, this is known as order. So if order is positive, it is like 1, 2, 3. In all those cases, this plot will be followed. In all those cases, this plot will be followed. But in this case, this will be 0 order, और यहाँ पे ये plot follow होगा. Clear? So in future, wherever there is a 0 order reaction, you will be calculating average rate, and wherever there is a first order, second order reaction, you will be calculating instantaneous rate. Okay, क्लियर? सभी को समझ में आ गया? इज ऑर्डर, ज़्यादा हिंदी में नहीं बोल सकते हैं भाई, बहुत सारे बच्चे हैं. आप IIT में जाओगे, when you go into an IIT, your professors will talk in English, your books are in English, everything is in English. Okay, so prepare yourself right from here. So order can be any value, dependence कुछ भी हो सकता है. Okay, dependence could be anything. ठीक है? So let's move ahead. How do we represent this? So average rate को कैसे दिखाया जाएगा? How do we represent average rate? Average rate will be represented as delta of concentration upon delta of time. Delta is a larger value. हाँ भाई, नॉलेज मैटर करता है, लेकिन आप पढ़ोगे भी तो। आईआईटी में लैंग्वेज डजंट मैटर, तो टीचर किस भाषा में पढ़ाएगा वहां पे आपको? Over here it will be written as d of concentration upon dt. Okay, so remember, instantaneous rate will be written by taking a slope, putting a tangent on the slope that we are obtaining, which is nothing but d of concentration by dt, and average rate is delta of concentration by time. Okay, it's very simple expression. एक सिंपल एग्जाम्पल से इसको समझते हैं, कैसे लिखते हैं. Okay, an important equation. Let's try to understand an important equation. Let's say there is a reaction 2A plus 3B gives rise to 4C plus 5D. Let's say a typical reaction is given like this: 2A plus 3B, 4C plus 5D. Can I say this is a balanced reaction? This is a balanced reaction. Can I say for this reaction, number of moles of A upon number of moles of B is in the ratio of 2/3? Can I say this? Number of moles of A upon number of moles of B is in the ratio of 2/3. Can I say this? Yes? Do all of you agree with me? Number of moles of A upon number of moles of B is in the ratio of 2/3. इस रेशियो में रहेगा. अगर मैंने B और C के नंबर ऑफ मोल्स का रेशियो लिया, तो नंबर ऑफ मोल्स ऑफ B अपॉन नंबर ऑफ मोल्स ऑफ C इज 3/4. ठीक है. Similarly, I can write number of moles of C upon number of moles of D will be equal to 4/5. Okay, 4/5. Can I do this? I take NB over here and 2 over here. I take C over here and 3 over here. I take ND over here and 4 over here. Can I do this? मैंने बस ये denominator को यहाँ ले गया and this numerator has been brought over here. Okay, I can do this. So my relation will become something like this. Can I say number of moles of A upon 2 will be equal to number of moles of B upon 3, which will be equal to number of moles of C upon 4 and number of moles of D upon 5. Yes? Okay? I have taken number of moles and I have tried to find out the ratio. Okay? फिर से वीडियो वॉच कीजिएगा, समझ में आ जाएगा. आप अभी आए हैं इसीलिए थोड़ा सी दिक्कत हो रही है आपको. सो नंबर ऑफ मोल्स ऑफ ए अपॉन नंबर ऑफ मोल्स ऑफ बी इज इन द रेशियो ऑफ जो उनके स्टोइकोमेट्रिक कोएफिशिएंट्स हैं. सो नंबर ऑफ मोल्स ऑफ ए एंड बी आर इन द रेशियो ऑफ 2 and 3. B and C are in the ratio of 3 and 4. C and D are in the ratio of 4:5. So coefficients are important. In the balanced reaction, the coefficients are important. So can I write this final equation? ये हमारा एक equation बनके तैयार हो गया. This equation of mine is done. Okay, this equation of mine is done. So अरे equation अरे NA by 2, won't it be NB by 3? NA by 2, isn't it equal to NB by 3? Also NB by 3 is equal to NC by 4. NC by 4 is the same as NC by 5. ये तीनों इक्वेशन को लेके यही रिजल्ट निकलेगा ना. ओके, दिस बेसिक मैथमेटिक्स यार, ये तो इक्वेशन, 3 इक्वेशन लिखा है हमने. ओके, सो अब 10th में है तो 10th में नहीं समझ में आएगा ना बेटा आपको. दिस इज नॉट फॉर 10th, दिस इज फॉर 12th स्टैंडर्ड. ओके, ठीक है, दिस इज क्लियर. नाउ assume that I observe change for these substances. What I do is I observe change. तो change observe कैसे करते हैं? डेल्टा लगा के. So I observe change in the concentration of A, in the amount of A, and divide it by change in time. Okay, I observe the change in A in a given amount of time. I will multiply this with 1 by 2. I observe a change in B in a given amount of time, in the same amount of time. I will divide it by 3, 1 upon 4, change in number of moles of C upon can I write this? I am changing A, B, C, D in a same amount of time. Can I say that this is how the equation will look like? This is how the equation will look like. Yeah, this is the whole idea. And we can do this. This is very easy. Okay, a lot of people have a confusion that why I am dividing it by 2. Why is this change divided by 2? The change is divided by 2 because the coefficients are arranged like that. Okay, this is the whole idea. Clear? This is the whole idea. Now tell me something, which is a reactant? So I'm like erasing this part. Let me write this thing again. So whether you take dA by dt or d of the concentration by dt or delta by t, I can always say this concentration of A upon del T 1 by 2, which will be equal to 1 by 3 delta of concentration of B upon T 1 by 4 delta of concentration of C by T, which will be 1 by 5 delta of concentration of D upon dt. I can write this. Now, Shantanu Joshi, please do watch the video again. You'll be able to understand. Okay, how I have obtained this result. Rest, except Shantanu, I guess you have understood this. Now tell me something, which is the reactant? Okay. Okay, which is the reactant? A and B. A and B is the reactant. If A and B is the reactant, then won't the amount of A decrease after a certain amount of time? So A and B will decrease, amount will decrease, amount of A and B will decrease, and amount of C and D will increase. Okay, amount of A and B will decrease and amount of C and D will increase. Clear? So what is delta? Final minus initial. Final minus initial. Will I get a negative value for this result, this particular change? Will I get a negative value or positive value for this change? बताइए. Delta means final minus initial. So final will be lesser than the initial amount for A. Final will be lesser than the initial amount for A. So will I be getting a negative value for this or positive value? I'll get a negative value. For B, I will be getting a negative value. Okay. For C, I will be getting a positive value. For D as well, I'll be getting a positive value. Okay. How do I make all these things equal? So these A and B give negative values, C and D give positive values. How do I make all of them equal? Is by putting a negative sign over here. Can I do this? I am getting a negative value for the change, क्योंकि change का मतलब क्या होता है? Final minus initial. Reactant का amount change करेगा. So if reactant amount is changing, final amount of reactant is less, initial amount is more. So this change is negative, this change is negative, this change is positive, and this change is positive. But to make all of them equal, I will multiply this with minus and minus. Okay? I will multiply this with minus and minus. Okay? So it is very, very simple. This is the expression that we will be working with. ये सारे expressions आप जो ले रहे हो, this all expression means rate of reaction you take any one of them, you will be getting rate of reaction. Okay, you take any one of them, the whole thing, 1 by 2 del A by del T times minus 1, you will get the rate of reaction, because I told you earlier that the rate of reaction can be calculated using reactant as well as product, and it will give me the same value. So if I use reactant, I should be getting the same value as the product. So how should I be getting the same value? I take the whole thing, this whole thing will become the rate of reaction. This whole thing will become the rate of reaction. This whole thing will become the rate of reaction. This whole thing will become the rate of reaction. You pick any one of them, you will get the rate of reaction. So it is not necessary to go behind each and every one of the reactants. You pick one of them, you will get the rate of reaction. Okay? You will get the rate of reaction. But what does del A by del T mean? इसका मतलब क्या है? The whole thing means rate of reaction. The whole thing means rate of reaction. But this small part, which is not multiplied by 1 by 2, means rate of decomposition of A. Rate of decomposition of A, or rate of disappearance of A. Okay, this means rate of disappearance of A. This part means rate of disappearance of B. This part means rate of formation of C. Now remember, rate of formation and rate of reaction may or may not be equal. May or may not be equal. Rate of decomposition of A is twice of rate of reaction. Can I say this? Rate of decomposition of A is twice of rate of reaction. Can I say this? Can I say this? Rate of decomposition of A is twice of the rate of reaction. Rate of decomposition of B is thrice of rate of reaction. Rate of formation of C is 4 times the rate of reaction, and rate of formation of D is 5 times the rate of reaction. When would the rate of decomposition and rate of reaction be equal? When this prefix is 1. If this prefix is 1, then only then they will be equal. If the prefix is not 1, they will not be equal. Clear? सभी को समझ में? बेसिक मैथ्स है यार, इसमें कोई झमेला नहीं है. सो हम क्या लिख सकते हैं? I'm writing it over here that rate of reaction is equal to rate of decomposition of A by 2, which is rate of decomposition of B upon 3. Okay? Rate of decomposition of C upon 4, sorry, rate of formation, not decomposition, formation, which is equal to rate of formation of D upon 5. ठीक है? Not moles are equal, prefixes are equal. Okay? Negative symbol, yeah, sorry, minus sign over here and a minus sign over here. माइनस माइनस यहाँ पे लगेगा, यस करेक्ट, माइनस फॉर रेट ऑफ डिकम्पोजिशन ऑफ ए, ओके. What will be positive and negative value effect? नेगेटिव साइन, हाँ नेगेटिव साइन लगाना है, यस यस. नेगेटिव साइन ओनली सजेस्ट दैट ये रिएक्टेंट है, रिएक्टेंट डिक्रीज कर रहा है, उसको रेट ऑफ रिएक्शन पॉजिटिव निकालने के लिए, इक्वल निकालने के लिए एज कंपेयर टू प्रोडक्ट्स, आई विल बी यूजिंग दिस. सो इन फ्यूचर ever you are being given a question, do not say that this thing is rate of reaction, okay. Del A by del T is rate of reaction. No, del A by del T times 1 by 2 multiplied by minus 1 is rate of reaction. Clear? Okay. So this is like the basics. This is the basics. In the next class, we will be discussing, so I hope this is understood. So आज के लिए बस इतना ही. In the next class, what we will be doing is we will be taking this further. We will be taking some questions on relation of rate of reaction and decomposition formation, and then we will be discussing orders of reactions and molecularity. Okay? It's a very easy topic. Try to attend every class. You will become very proficient. Okay? So it's a lovely one topic, and it does not involve a lot of chemistry. It looks like basic physics का ही lecture चल रहा है. ठीक है? चलिए. So this is Saurav Goswami signing off, and I wish you all have a lovely day ahead. Okay? Bye bye guys.